maximum, and this is the largest function value in this domain. That's the absolute maximum. We also have the local minimum, and this is the smallest function value in an open interval in the domain. And in the same category, we have the local maximum, which is largest value in an open interval in the domain. So if I look over here, this is a minimum, and also this is a minimum. In this neighborhood, or in this part of the domain, this is a minimum, and it just also happens to be the lowest point of the graph. So that's why we call it the absolute minimum. We also have the local minimum, meaning that in this neighborhood, that's the lowest point. And also in this neighborhood, or this part of the domain, that's the local maximum. And look at this one. That's another local maximum. This is the absolute because the highest. This is the local minimum. Note the graph keeps going down. This here is the local minimum and the local maximum. Again here, this one has local maximum, local minimum. And that's how you can be able to tell which one is the local and then which one is the absolute. Let's look at how we can analyze polynomials. And here we have a table, and we have some questions to answer. And let's read the question. It says here, information about a polynomial function g is given in the table. Which statement is guaranteed to be true about g? So it's saying which one must be true. And I can read these statements, but they don't make much sense if I don't sketch. So I'm going to make a sketch. I'm going to sketch what I have here. So I have negative 5, 8, 1, 2, 3, 4, 5, negative 5, and this is just a sketch. So 1, 2, 3, 4, 5, 6, 7, 8. So I'll say 5, 8 is right there. And then what do I have next? I have negative 2, 11, 1, 2. I'll just make this one a little higher. And let me make that line here so that I can be able to tell that interval. Okay, the next one is 4, 2, 1, 2, 3, 4, 2. I'm just approximating. It's right there. And what else do I have? 1, 2, 3, 4, 5, 6, 7, negative 4. I'll just approximate there. Just approximating, just a sketch to help me. Okay, so what do I know about g of x? From negative 5 to 2, from negative 5 to 2, it's telling me that it's increasing. So what I'm going to do, I don't know how it looks like. All I know is that it's increasing. So I'm just going to connect. So that's increasing. And then, so from negative 2 to 4, I'm told it's decreasing. So I'm just going to go down. Okay, remember increasing is going up, decreasing going down. Then 4 to 2 is decreasing. And what happens after that? From 4 to the next point I have, it's still decreasing. So just go down. So now I'm going to look at my statements and see which one could be true. The graph has a relative maximum at x is equals to 2. So is that the highest point I see? That looks like a relative maximum. But let me read the others. The graph has a relative minimum at x is equals to 1, 2, 3, 4. That's not true. The next one, g of x is equals to 0. You're telling me this is an x-intercept in the interval negative 2, 1, 2, 3, 4. And I know that's not true because there is no intercept. There is no intercept in this region from negative 2 to 4. There is no x-intercept. So I can tell this one is and the range of the graph is negative infinity up to negative infinity up to 11. But I don't know what is happening. I don't know anything about the other part of the graph. I do not know. So I cannot say that for sure. It could be, but I do not know. So the only thing I know for sure is this one, because I see this here is a relative maximum at x is equals to negative 2. Another example here. Information about a polynomial f is given in the table below. Which of the following statements is true? Okay, I'm going to sketch it, because when I sketch it, I can be able to see it more clearly. So I sketch it, and when I sketch it, what do I see? Okay, let me make my sketch. So and I have 1 2 3 1 2 3, that's negative 3, and I'm going to say negative 3 1 2 3 4 5, just an estimate. Okay, negative 3 5. Okay, that's my first point. And the next one is 3 to 5. So I have 1 2 3 4 5, and it says 11. Let me just assume 11 is right there. I'm just guessing, just estimate. I just need a sketch. And okay, so that's negative 3, and this is 5 1 2 3 4 5 11 right there. And what do I have another? Okay, yeah, those are my 2 points that I have. These 2 points, these are the points I sketched, these 2. And all I'm going to do, let me look at what they have given. If x is less than 3, it's decreasing. So that means it's decreasing, going down. The graph is decreasing. And then from on the next interval up to x is equals to 5, I know it's increasing. And greater than 5, just increasing, just going up, just going up. So now I'm going to check what I have. It's increasing, actually it keeps going up, decreasing. So that's all decreasing in that, on that interval, less than 3, decreasing. Okay, now what do I know? F has a relative minimum at minimum value of negative 3. Is that true? I mean, I think this should say at x is equals to negative 3. But when it says a minimum value of negative 3, that's not true, because the minimum value is actually, in this point, is 5, because the coordinates are negative 3, 5. So if I was to talk about the minimum value, then this would be 5 and not negative 3. So I know this one is out. I go to the next one. 5 11 is an ordered pair of the relative maximum. Okay, I know this is 5 11, but that is not a maximum, so that one is out. Okay, now let's go to the next one. 5 f of negative 5, so that's going to be, let's say here I go up, so we're talking about a value there. It says is less than f of negative 3. F of negative 3, no, actually that value is greater, because f of negative 3 is here, so I'm not even going to check the other one. So that means none of the values is correct, and I'm going to say none of the above. And that's how you can be able to sketch it and be able to check all the statements which are given, and that's what to do.